Another way is that we're going to invite interns from graduating students in high schools and technology colleges in the area, like the Southern Oregon Institute of Technology and the College of the Siskiyous, to ask graduating students to be interns, to act as tour guides and educators for the general public about the whole ecological, technological program and social program of this building, so that they have a chance to meet the public every day and to exchange ideas and to share what we're trying to do, which is basically changing the world, changing people's thinking and behavior. And they become, these young people become leaders for promoting this change, and they have now an opportunity to do that. So, so these are the kinds of issues we're dealing with in sort of a larger picture of things, of the function of this building. Now, technologically, the building has many interesting things. It's like a living organism. It might be easier to think of it that way. It's creating its own renewable energy through wind and sunlight, and that's done through slow-turning windmills and photovoltaic solar cells on the body of this building. And it's also creating its own water cleaning systems using wetlands, using nature's plants and nature's processes to clean water and to clean raw sewage water as well. So we're letting nature, nature's processes help us to clean our water.
How do you plan to do that?
Through wetlands. Well, there's a series of ways. One is there's a waterfall on the building that oxygenates the dirty water, kills the bacteria as it falls, and then helps to clean the water. The water goes back into these wetlands, and the wetlands have special water plants that eat up the bacteria in the water, and that's recycled back into this marine area that further cleans the water, and then that's pumped back into the building as gray water. So it's recycled and used again. And these are proven technologies. There's probably 400 to 500 wetlands, human constructed wetlands in the United States and other countries, and this is a proven technology. In fact, on one test using water plants, raw sewage water was transformed from sewage to 5 times the level of certification for drinking water at the end. So it's a proven technology and it works. It's also inexpensive, and it's let nature doing what it naturally wants to do, which is clean water.
Tell us about your design for the building, what's going to be on each floor, whether people are going to live there, you're going to have a teaching center, you're going to have class.
Here's a picture of what the building might look like from I-5. And you see that the building is basically a bridge structure. Now, why is it a bridge structure? Why would you do that? Well, because a bridge only sets down on the earth at the endpoints. And if you want to protect the planet, then you have to find ways to create buildings that minimize their footprint on the earth. And the bridge, this bridgeway, is a perfect example of how that might be done, because it only sets foot on the planet in 4 spots. Actually 5. There's a place in the middle too. But let's say 5 spots, and we calculated that the total square footage of those 5 spots together is less than 500 square feet. So can you imagine, this building is almost a football field in length. It's 100 feet wide, but it only touches the earth in 500 square feet. That's remarkable.
Nice.
It also allows wind to travel through the building for natural cooling, and it allows the north and south winds to travel in and around these open areas to cool and to operate these windmills and the photovoltaic panels that are here. So the building is an example. Oh, by the way, in disasters like earthquakes, high wind situations, flooding, fire, the material is fireproof. so there's no problem with
You
it
want to
burning.
show the material?
But then, yeah, the material is like, I'll show this one. It's like this, and this is a translucent, I don't know if you can see that, it's a translucent sample of the building. So you could see through it. Well, we're going to make it transparent. So you'll actually be able to see through the building and see all of the operations, all the utilitarian water flows and electricity lines and everything in the building. And the building will light itself. So that means that there's no need for fixtures because the building is its own fixture. Now can you imagine that? It's like, see, you remember those deep sea creatures where that have these undulating flashing lights going through their bodies? That's sort of like what this will be. It'll be a sort of an otherworldly organism. So, and this material has international code, has been approved, code approved, and is fireproof, waterproof, 1,000 times lighter than structural, and is insulative in a high degree, very insulative. 1 inch is about R8, so 3 inches would pass code very easily. So we're using a new kind of material, and to allow the building to be transparent. And then also the building has this waterfall system, and it has this opening and closing cocoon, is what I call it, a cocoon. So the building opens and falls down into this water basin and disappears, so that suddenly you're out of doors. You're in this outdoor pavilion, and you can see all around you 360 degrees through Mount Shasta, the Eddy's Black Butte, and the whole range. And this water pond down here that this cocoon falls into is warmed by the sun in the wintertime and cooled by the water in the summertime. It's cooled by the water in the summertime. So it acts as a natural air conditioning heating system because the building is suspended over this giant pool. And the pool is there also to help buoy up the cocoon so that the energy used to open and close it is much less. So the building, as you can see, is basically a living organism in itself. And when you go inside, there's 4 levels. And the first level is the residential level. So it would be, what would the residence of, what would an ecologically based residence be like? Or let's put it another way, what would the residence of the future look like? The future that is a part of nature, that's aligned with nature. Well, it might have internal water systems that you could see for cleaning water in your environment. It would have plants and trees for maintaining the temperature and humidity and air quality of your living environment. It would have transparent, translucent wall systems, so that suddenly if you wanted to see outdoors, you simply push a button and all of your walls become transparent at the same time. So you see without any obstruction. These are the kinds of things. And it would have maybe solar ovens, things that minimize the use of energy and maximize your connection to nature. The second floor, and you go up these helical ramps, the second floor would be the public exhibition and lecture performance areas. And this is where people come together from different parts of the world to give presentations about their own work, about the different states of the planet around the world. For instance, we might invite John Todd, who's working with creating living machines, that is, using nature to clean water. What was he doing to improve the condition of the planet by implementing these machines?